So now the next two sections or next two modules are slightly superficial. It basically talks about what industry is doing for finding vulnerabilities in web applications. It's not a very comprehensive discussion on how to find vulnerabilities. It's about what are the practices in vulnerabilities. So program analysis based techniques usually are used for static analysis based vulnerability detection. Sometimes you use dynamic techniques where you actually create a sandbox and run the code and collect data, and from that you analyze and check for vulnerability, signs of vulnerability. So those are the major techniques, and we could actually have a whole course on such techniques on static analysis and dynamic analysis of web applications. But here we are just talking about what is done in practice. So there are many web vulnerability tools from various companies. So some of the big companies are like IBM, which has a tool for scanning. Acunetics also is a pretty good name. Rapid7, McAfee from Intel, Senzik, and HP has Fortinet. But usually they are very expensive, and sometimes some of them are embargoed in the country where they are actually built, so they cannot be exported sometimes. So a typical scanner dashboard looks like this. So it basically allows you to, so there are vulnerability classes, and for various vulnerability classes these tools could be doing static analysis, doing dynamic analysis. It could actually do testing, penetration testing, by sending various kinds of inputs and looking at this, and then it actually gives you nice summary. As in charge of security of your entire web presence of a company, you would like a dashboard like this, where you can actually look at the various places where vulnerabilities are, how many vulnerabilities are being detected, what they found in terms of port scanning and all other things. So it's not only just about the web application code vulnerability, but this kind of dashboards actually also have many other information about your network vulnerabilities. So this shows a typical test vector by category for a particular scanner. So test vectors means that it creates various kinds of URLs and various kinds of SQL injection and various other things, and then it tries to see whether the server falls victim to any of these. So usually, for example, as we were saying, that the exfiltration or information leak vulnerability testing seems to have about 50% of the share of all the testing. XSS also is about 20%, and SQL injection is more than 10% and so on. So here is something that the Stanford guys did, is that they look at the National Vulnerability Database, so NVD, which is maintained by NIST, which is the National Institute of Standards and Technologies in the US. So National Vulnerability Database, for example, lists all the known vulnerabilities. So what they did is that they took an industry scanner, and then they basically took multiple different applications that are used for web application building, and then they checked, compared to the NVD report, and they took the old versions, previous versions of all this, because if the vulnerability is already declared in the NVD, then that means that has been fixed in most cases, and therefore they took the past version, and then they say, okay, let's run the scanner and compare how many of the NVD declared ones can be detected by the scanners, and then turns out that it did pretty well in the session hijacking kind of attacks. It did quite well in the information leak kind of things. For CSRF, it found none of the four. In case of Drupal, in this case only in WordPress Strayhorn it found one. Session is consistently doing well in all the scanners, it seems, but if you look at the XSS, it's doing about half in all cases. SQL injection is doing about half or one third. XCS, which is basically a cross-channel scripting, where the scripting is the scripts are kind of injected into the system not by a web channel but other channels, for example an FTP or file system, or through SNMP and things like that. So in that case also it didn't do very well. So what the conclusion was for the guys there is that scanners are not necessarily foolproof way of knowing that your system has no vulnerability or has vulnerability. It can detect some, but it cannot detect all. But it also sees that certain types XCS and CSRF also had a low vector count, as we saw the test vector count, and that might be the reason, or it could be that these are attacks that are not very easy to figure out with scanning. So overall detection rate, they found that 62% of the NVD type 1 excesses were detected, only 15% of the type 2 was detected. So type 2 is the stored type, whereas the type 1 reflected one is the 62%. And then it found SQL injection first order 21% and so on. So what all this is saying is that scanners are essential, but they are not sufficient.